Right, so the next two transformations we're going to look at are the vertical shifts and amplitude changes. And these are probably two of the easiest ones to do because of the values that stay the same and the values you have to change. Okay, the arithmetic today is going to be a lot easier than it was yesterday. We're not really going to be dealing with pi too much or bless you, common denominators. You won't have to worry about that. All right, so the first thing is what is the amplitude of a sine or cosine wave? Basically, it's the height. Okay, it's the height of the wave measured from that center line. Okay, and as far as it goes above the center line, that should be symmetrical with as far as it goes below. Now, yesterday, every problem we did had the same amplitude. Okay, what was the amplitude of all the problems in the homework? 1. Okay, the highest it went was 1. Okay, today we're going to change that. Okay, so the amplitude is a height. Okay, since it's a height, what kind of number does that mean it has to be? It has to be positive. So if I ever ask you for the amplitude of a function or of an equation, your answer should always be a positive number. All right, so next thing we have to look at is what does an amplitude change look like? Okay, this time you're not going to add or subtract something inside parentheses, okay, next to your argument. This time you're going to multiply by a number in front. Okay, so 3 sine x, that's an example of an amplitude change. Okay, negative 2 cosine x, okay, that's another example of an amplitude change. And this is an amplitude change, but it's doing something different than the first two. Okay. Anybody have a guess why the third one is going to be different? Yeah, that's going to be compressing. Okay, so when I showed you stretching the graph, I also showed you I can compress it, just like it is right there. Okay, so now when we do graphing problems, you get a new type of thing to look for. Did I add or subtract a number next to x in parentheses, or did I multiply by a number in front? Now, this negative in front of that 2, it has nothing to do with the amplitude. It does have to do with the sketch. Okay, the only thing that affects the amplitude is that number right there. So whether I put a positive 2 or a negative 2, that doesn't affect the amplitude. Okay, the negative only affects the picture. Okay, that's why if I ask you for what the amplitude is, you always take the absolute value of the number in front. Okay, so if I ask you for the amplitude, the negative does not matter. If I ask you to sketch it, the negative does matter. Okay? So let's do these 3. Let's find their amplitude. Okay, what's the amplitude of the first one? 3 sine x. 3, yeah. It's the absolute value of a, and a is the number that's in front. So the amplitude there, 3. What's the absolute value of negative 2 cosine x? Yeah, just the absolute value of the number in front. And what about the amplitude of 1/2 sine x? 1/2. Okay, so there'll be a couple questions on the test, just like that, where you don't have to graph them. I just give you a function. I say, what's the amplitude? Okay, what would be the amplitude of that?
2.
It's still 2. By getting rid of that negative, I didn't change the amplitude, but I did change the picture. Okay, you'll see what the negative does in a little bit. Okay. Questions on finding the amplitude if you're given an equation? Let's do one more. What's the amplitude of that one? What did you say, Kate?
5.
I think it's 5.
Maybe not.
Yeah?
Maybe 1.
1? Okay. Guess for 5 and a 1. Any other thoughts? You got a tiebreaker maybe? I'll tell you, it's one of those two. Dan? Jared?
5.
It is 5. Yeah. All these other numbers, they do other things. Some things we've studied, some we haven't. Okay, the plus pi is a phase shift. That has nothing to do with amplitude. The minus 4 we're going to study next today. That's a vertical shift, down 4. That doesn't affect the amplitude. And the 3, that's not something we're going to study till Thursday. Okay, that's the period change. Okay, the point is, you can put any other numbers you want in here. That's the only number that affects the amplitude. Okay. And this is also a function that has 4 transformations in it. I would never ask you to graph one like this, but I might give you a problem like this and just say, what's the amplitude? And tomorrow I might give you the same problem and say, what's the period? Okay? And we'll learn how to do that. Okay, so really kind of the number here that makes a difference whether you're stretching or compressing your graph is the number 1. Okay? If you take the absolute value of your number, is it bigger than 1? Okay. 2, 5, -10, -13. Any one of those numbers I just said causes the graph to stretch. A negative, like -10, the 10 causes it to stretch, and then the negative causes something else to happen. Okay, but any of those numbers cause a stretch. Compression, that occurs when the absolute value of A is less than 1. 0.5, 0.7, -0.8. Any of those numbers I just said will cause the graph to compress. The -0.8, that'll cause the graph to compress, and the negative causes something else to happen. Okay, so any questions on whether a graph is going to stretch or compress? How you tell? Okay, let's look at the ones we just did. The first one, is that going to stretch or compress? Stretch. Yep. Second one? Stretch. Third one? It's going to compress. And the last one? That stretches. Okay. And if we wanted to be more specific, we could say, it stretches by a factor of 2, factor of 3, whatever. Okay. All right. So now we know what an amplitude change looks like. We know how to figure out if it's going to stretch or compress. Next thing we have to do is find those 5 important points. Okay, the 5 coordinates when we graph it. Bless you. Okay, what's going to stay the same? Bless you. Since we're going to stretch or compress up and down, this time your x's stay the same. If we're going to stretch and compress up and down, that's the y's that are going to change. Okay, and what's nice about the x's staying the same? I said earlier, I think that'll make it easier today, but how come? Yeah, we don't have to deal with any of the pi's, pi over 2. So I can already tell you your x coordinates for every single problem we do today. 0, pi over 2, pi, 3 pi over 2, 2 pi. Every single problem in the homework today. Okay, the x's are not changing. Okay. So if the x's aren't going to change, the y's are. Very simple to find the new y values. Just take the old y values and multiply by a. Notice it does not say absolute value of a. Okay. Only time you take absolute value is if I ask you the question, what's the amplitude? It's got to be positive. So if there's a negative with the a, you're going to use it. Okay? If there's no negative, well, you don't use it. Okay? But just take the number exactly the way it is. Okay? Whether it's half, -2, 5, doesn't matter. Use it just the way it is and multiply the old y values by it. All right, so let's try this one. 3 cosine x. Okay, so now we've learned 2 transformations: the phase shift, amplitude change. Who can tell me which one is this, and how do you know? Is it the period change or is it an amplitude change? Katrina? Yeah, it is an amplitude change because that's what we're studying today. But besides that, how do you know it's amplitude?
Because it's in front of the cosine, it's positive.
All right, it could also be a negative for an amplitude change, but what else? The number is in front of the cosine, and what are we doing with it? What operation? Multiplying. Okay, that's the key. You're multiplying by a number in front. Okay. How does a phase shift look? Where do I put the number, and what do I do with it when I'm doing a phase shift? It's in parentheses with the x, and because this is also in parentheses with the x, but it's not a phase shift. You're adding or subtracting. You're going to learn that on Thursday. Okay, so you're adding or subtracting. All right, so we know it's an amplitude change. Nolan, what values did we say stay the same? Yep, so for every problem today, pi over 2, pi, 3 pi over 2, 2 pi. Okay, now I'm going to write down my old y values off to the side, and then we'll figure out the new ones. Okay, so Nick, what are my old y values?
0, 1, 0, -1, 0.
Yeah, nice catch there. What ones were you giving me at first?
Sine.
He was giving me the ones for sine. Okay, most likely that will happen on the test. Somebody usually does that. So try to make sure you read the right ones, just like Nick did. All right, now we take the old y values, and in this case, I'm going to multiply them all by 3. Just going to triple them. Okay, put all your answers right in that table. Okay, so just sending it. Can you tell me my new y values?
3,
Yep.
0, -3, 0, 3.
Yep, that's it. That's an amplitude change. Okay, a lot easier, I think, than phase shift in terms of arithmetic. Questions on that table? Okay, same method of grading as I explained yesterday. 1 point for each x and y, 2 points for the graph. All right, so now the way I'm going to set up my graph, I'm just going to mark the highest line as 3, and the lowest is -3. So I'm going by 3s on the y-axis. On the x-axis, I'm just going to label it like I normally do. Okay. Pi over 2, pi, 3 pi over 2, 2 pi. And now graph your points. So we've got 0, 3, 0. I think that was a negative, but my 3 kind of made it look like it was a part of the number. So -3, 0, back to 3. And there's your sketch. Okay, any questions on the sketch? Okay, so one thing you might notice today is a lot of our graphs are going to look the same, and that's because I'm going to change the scale. So let's say that I wanted to graph 6 cosine x. Okay, I'm going to change it back in a second. Say you wanted to graph 6 cosine x. The only thing I'd have to do, make that a 6, and make that a -6. Now I just graphed 6 cosine x. All right? So that's why a lot of them are going to look the same, because I'm going to change my scale. Okay, any questions on that idea? All right, so why don't you guys try, try that one on your own. Okay, 1/2 sine x. See if you can get your table, make your sketch, and then I'll come around and we'll go over it together. All right, so this one, 1/2 sine x. Okay, it is an amplitude change. Just by looking at it, anybody tell me, is it going to stretch or compress? Yeah, it's going to compress. All right. And Sam, can you remind me again what values stay the same?
The x's.
Yep, x's. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And if you want to just jump right to your final y values, you can. I find most of the time it's less confusing if you just put the originals first, kind of off to the side, and then put the new ones. So I'll put my originals. Kate, can you tell me my original ones?
0, 1, 0, -1, 0.
Yep. And what are we going to do with each one of those?
Multiply them by half.
Yeah. So 0, 1/2, 0, -1/2, 0. How many people got that as their table? Yeah, most people. All right, good. Okay, so again, 1 point for each x and y. And now I'll make my graph. Did anybody scale it with 1/2 as the top line and -1/2 as the bottom? Yep, you could do it that way. Did anybody put an extra line in here and call that 1/2? And call this -1/2? No, you could do it that way too. Okay, I think I'm just going to stick with 1/2 and -1/2. Okay, so I'll just graph it. 0. Okay, pi over 2, I'm at 1/2. Pi, I'm back at 0. I'm going to put 3 pi over 2 up above it, just so my graph doesn't go through that. And 2 pi back at 0. There's your sketch. What's the only thing I would have to do to this picture to make it the original? I just have to change two things. Yep.
The 1/2 and the -1/2, the 1 and -1.
Yep. Just make those 1 and -1, and there's your original picture. Okay. Any questions on that one? No? Okay. Okay. What's different about this one compared to the last two we did?
What's a negative?
Yeah, it is a negative. Technically, there's a number in there still. What's the number in front of cosine?
1.
Not 1 this time. No, not 0.
It's technically -1.
It's technically -1. Right?
You asked what was in front of cosine, in between the negative and the cosine.
Oh. So, we've got a -1 in front of cosine. And technically, that's not an amplitude change, because what's the amplitude of this function? It's still 1, but the negative is going to do something. Yeah, it's going to flip the graph over. Okay, so you're going to get the same graph for cosine flipped. All right, so let's make our table. And normally my y values for cosine would be 1, 0, -1, 0, 1. It would have kind of that V shape when you graph it. Well, this one, I'm going to switch the sign of all your y values. And it's going to look like that V shape flipped over. So we've got -1 to 1. And we got 0, -1. Pi over 2, 0. Pi, we're at 1. 3 pi over 2. Back to 0. And 2 pi, I could have put my label above it, but that's fine. Okay, and remember, just like the wave, it's always curved. So try to just do your best with that. And that would continue. And that's it. So that's all that a negative does, is it causes it to flip. If this was other than a -1, let's say it was a -2, all I would have done here is labeled this 2 and -2. Okay? So any questions on what a negative does? All right, so that's our first transformation, amplitude change. And the period change, I think the arithmetic is even easier. I'm sorry, vertical shift. Okay, vertical shift arithmetic is very easy. So a vertical shift has the form sine, or it could be cosine, either one. And you're adding a number onto the end. Now I thought phase shift was when you added or subtracted a number. So how is that different from a phase shift? It's on the outside. Very big difference. Okay, if you add or subtract a number outside the parentheses, that's a vertical shift. Okay. That's an example of a vertical shift. Now, if everything worked nicely and you didn't have to do the opposite, what would you expect this would do to the sine function? Shift it 2 units which way? Up, and it does. Okay. Vertical shift and amplitude change are the 2 functions that you do exactly what you see. Bigger numbers, make it bigger, stretch it bigger. Small numbers, like fractions, make it smaller. That's what you would expect. Positive numbers, shift it up. Negative numbers, shift it down. You do not do the opposite. Okay? Phase shift, you do the opposite of what you would expect. And so with period change, you do the opposite of what you would expect. Okay, so a vertical shift moves the function up if you add a number, and it moves it down if you subtract. I think the biggest mistake people make with this is they just mix it up with a period change. They just do the opposite, and they get it wrong. Okay, so just don't do the opposite. All right, so before we can graph, we just have to figure out where those five important coordinates are going to move, how they're going to move. So we're going to start with the original table, and one of the columns will stay the same. Okay. If you shift up and down, what values are going to change? Yeah, we're changing the y values again, because we're going to move up or down. So again, the x's stay the same, and whenever they can stay the same, that's a good thing, because we don't have to deal with pi's or fractions or common denominators. So now we have to get our new y values. Anybody have a guess what we're going to do with this number or this number and the original y values? That's pretty much what you would hope it would be. Yep. Yeah. So like in the first one, you take all the original y values for sine and you would add 2. For the second one, you take all the original y values for cosine and you'd subtract 3. Okay, so to get the new y values, either add or subtract d, which is that number, to all the original y values. Don't do the opposite. What was the name of the transformation we learned yesterday? Phase shift. Phase shift, you do the opposite. This one, you don't. All right, so we'll finish up with 2 vertical shifts. We'll do We'll do one sine, one cosine, either up or down, and then we'll do one that's the opposite, either up or down. Let's do it. Okay, so the first one we'll do is we'll shift sine up 2 units. Okay, if you need to, you can make your original table, which I usually do. I just make that third column off to the side to put all my numbers in. And Brianna, what column is going to stay the same? X's or Y's?
The X's.
Yeah, X's, because this is a vertical shift. Vertical. It's going to change the Y's. 0, pi over 2, pi, pi over 2, 2 pi. And Karen, what are my original Y values for sine?
0, 1,
Yep.
0, -1, 0.
0. And can you tell me what I'm going to do to all of them?
2.
I'm going to add 2. Okay, we're going to add 2 to all the Y values. All right, so when we add 2 to all the Y values, arithmetic, very, very straightforward. Okay, just add 2. 2, 3, 2, 1, 2. Okay, any question on the values in the table? All right, so now to graph it, I'm just going to label this 1, 2, 3. Just go by ones on the y-axis, and label your x-axis just like always. And yes, you do have to label the x-axis for each problem. There's only 6, I think, on the whole test, so at most you're going to have to label it 6 times. All right, so okay. 2 pi over 2, we're at 3. Back to 2, -1, and back to 2. There's our graph. Again, no real connection with sound. I don't think I played the connection with sound for a amplitude change, but if you just read what the slider does, it's a change in the volume. Okay, when you stretch or compress, changes volume. This one, I can't demonstrate it for you. What's the amplitude of that function? Yeah, Jake?
1.
The amplitude is 1. Yes. Okay. What's the maximum value of the function? 3. Okay, little bit of a difference there. A lot of people say, oh, 3 is the amplitude because that's how high it goes. No. Amplitude is the height off of the center. Okay? This has an amplitude of 1. Okay? And there's no number in front of sine other than 1. Okay. So any questions on that one? All right, so let's look at our last one. Okay. Cosine x minus 5. So Jared, out of the 3 transformations we know, phase shift, amplitude change, vertical shift, which one is this? Yep, perfect. How do you know? Yeah, the number's after the cosine x, and you're subtracting. What if I did this? Someone else tell me, is that still a vertical shift? Eric? Well, what other option are you thinking it could be? The phase shift. Okay, that would be another reasonable choice. It's not an amplitude change at all. What did I say you have to have, though, for the phase shift? You've got to have parentheses, okay, around the letter and the number. That's a phase shift. Okay, when I did it like this, those two are actually the same problem. What if I did parentheses like this? Is that a phase shift now? I got parentheses. Sam, how come that's not a phase shift? Right, it's not around the number. It's got to be around the letter and the number in the same set of parentheses. So even if you did this, okay, yes, I have parentheses around the letter and the number, but they're not together. Okay? These are all the same problem. Okay. All right, so let's make our table. Okay, x's, again, those stay the same. So Skylar, can you remind me, what are my x's that I'm using for every problem today and in the homework?
0.
Yep.
Pi over 2. 3 pi, or pi, sorry. And then over 2. 2 pi.
And 2 pi. All right, so got my x's. Now my normal y's, they start at 1. 0, -1, 0, 1. And Jesse, what am I going to do to all those y values? Yep, subtract 5. Should I do the opposite? No. Good. Don't do the opposite. All right, so subtract 5, and now we'll just write your answers. Okay, so what are my y values here, Kyle?
-4, -5, -6, -5,
-4, -5, -6, -5, -4. Okay. Any questions on that? Did that left side disappear for a little bit?
Yeah.
Okay, just checking. So now we'll just graph those values and we're good. So 0, -4. Okay, pi over 2, -5. Where am I at? Pi, -6. Wait, I'm off one. I'm going to label these first. Pi over 2, pi, 3 pi over 2, 2 pi. All right, so 0, -4, that one's good. -5. A little difficulty. -6. -5, -4. Okay, you know if you don't get that V shape, like I was getting a point that was off, either I did something wrong in my table or I labeled my axes wrong. In my case, I labeled the axes wrong. And there's your graph. Okay. Any questions on that? Okay, so now at this point I've taught you 3 out of 4 transformations. The last one we'll do tomorrow is a period change. Okay, so the homework tonight, again, just like last night, will be a worksheet.